So hopefully everybody sees the right way to look at this. The biggest mistake is that whole JAWS thing. Coming from below doesn't mean, it doesn't. It means as x approaches the number, what are the outputs doing? The outputs look to be going to 2. And of course, as you go from above, the outputs all seem to be going also towards 2. And you can see that directly on the graph itself. They agree on where they're both headed. Do they get there? No. So that's going to be, the function's going to have a problem there. Not the limit. The limit actually never gets there. So the limit from above is 2. So what's the limit just overall? 2, because I can consolidate these two into one statement. If these don't agree, I can't consolidate. This wouldn't exist. But what's f of negative 4? Undefined. I love it. If you say does not exist, you're fine, because I think the book says that too. But officially, we know this is undefined, where there's a circle, an open hole there. What about 1? You already know what's going to happen for the limit overall, right? But what does it look like as you approach from below? What are the outputs going towards? Four. I like it. And as you approach from below, what are the outputs going towards? Negative 2. So what can I say here? Does not exist because they don't agree. They can't agree. What's the agreement? There isn't one. It doesn't exist. And then, but what's f of 1 though? Beautiful. The filled in part is at 4. So that's what f is there. It's 4. So function at a point completely cares about what's happening at that value. Limits don't give the first shit about what's happening at the value because they don't get there. That's why they were remarkably useful for weird places. What about 6? 6 is just like this one to begin with, right? I mean, because from below it looks like to be going to 5. From above it's also going to 5. So the limit is 5. Well, what's the function? What's f of 6? 2. Because that's where the dot was put. Kick ass. Let me ask you this. If you wanted to call different problem areas different names, which ones would you call, this is the easy one, which one would you call a jump discontinuity? Where would there be a jump discontinuity? Where's the function jump? Yeah, at 1. It jumps, right? Or, falls. But in math, we just call a fall a negative jump. The name for these two is not the easiest, but if I do look at this as a road, this would be what in the road? A giant sinkhole or pothole, right? So could I fix it? Could I remove the problem here? Yes, I could fill it in. So this is what would be called a removable discontinuity. If I define f of negative 4 to be 2, it would be continuous there. You guys with me? So those names actually make physical sense. And the only other one that's not on here is an infinite discontinuity, where they just go to different infinities. So that would be an infinite discontinuity. Or they can even go to the same as infinite discontinuity. Okay, maybe. What about this guy? Let's see. Let's try to use this calculator trick. Oh man, I don't want to mess with this. Let me turn him off. Scheisse. Put in here this business. Tangent x minus pi divided by x minus pi. Okay, so let's see. Scheisse. So let's put in 3.1, 3.13, 3.141. Now you can see right away there's just not enough detail there, right? Okay, so this is not always the best option, but this is the option I always try first, just in case it's kind of like quick and easy. But what'd you guys get when you put a 3.1 in? That should have been 5 something, blah. What about 313? 3.141?
1.0000001.
Okay. Probably same thing for this, right? So I mean, it's pretty quick. This one I didn't have to get as close even. What's the limit look to be? 1. I love it. Can I do this type of idea on this? Is there an algebraic thing you can do?
No.
No. So the table is sometimes the only real way right now we have to analyze it. When we learn some more calculus, there will be another way, that L'Hopital's thing I talked about earlier, that'll make this so easy. But there's a lot of shit we don't know before we can use that. I like it. But right now this wasn't that bad. Looks like the limit's 1, and if you graph it, you can actually see that the limit does appear to be 1. Okay, is everybody cool with that one? Now if you had degrees turned on, you got some really weird ass stuff, but just be careful about that. Now this first one's easy. It's very obvious what you do. What do you do with this guy? Actually, and be really careful. I didn't do this on here because I wasn't trying to be evil yet, but on a quiz or a test, I will put something like, let me do it up here. I will put something like this. Can you read that? Let's really slow down. I don't have to do anything algebraic. What's the very first thing you should do with these kind of problems? Just try to plug 1 in. See if there's a problem. What do you get when you plug a 1 in?
1.
What do you get when you plug a 1 in?
0.
0 over 3. Is that indeterminate? What is 0 divided by 3? I can determine that. It's freaking 0. Or if it was 3 over 0, that is determinate. It's infinity then. You guys get what I'm saying? So don't just start attacking shit with algebra before you even check to see if you have to. Maybe just get the answer directly. So on each of these you can't. You plug a 3 in, you get 0 over 0, right? I believe, yes. So of course you factor this bad boy. So you can take a 4 out, and then this is just a difference of squares. Die. Now you can plug a 3 in. Yes, sir.
If 3 would have worked here, would we still need to factor it if it can be factored?
No.
Okay.
Because you just plug it in and get the number.
Okay.
Yeah, because all I want is the answer, the number answer. If it's indeterminate, that means you have work to do. If it isn't indeterminate, you should be done when you plug it in. That's the difference. Kind of makes sense. I love the name. Indeterminate. Okay, we got to do something to determine the answer. Determinate. I'm done. I see the answer. I'm done. So that's beautiful wording we chose. We're not always the best at choosing words, math people. I understand. And so what do you get here? 24. I love it. Kick ass. Bam. What do you guys have to use here? One person asked me and I told them.
Conjugate?
Conjugate. So you're going to multiply top and bottom by? I like it. 3 plus radical whatever. So on the bottom, I just get 2x times 3 plus rad x plus 9. On the top, I'm going to get 9. Now this is where you can make a real easy mistake. 9 minus, right? 9 minus what? What's rad x plus 9 times rad x plus 9? X plus 9. Because half of it times another half of it is a whole it. Aw. Right? But if you do this, you're not right. Because it's minus the whole thing. So that's a really easy mistake to make. The stupid negatives always get us. Right? It's like nature in Jurassic Park. They always find a way. So what happens on the top? Don't forget your limit, by the way. Let me be really careful here. You've got to continue bringing this with you because it's what's letting me do some things here. And plus, I don't want to lose the question. So I'm sorry, go ahead. What happens? The 9s cancel, and then the x's. And weren't these the problem? Because I'm trying to let x go to 0. I couldn't because there's a factor of x on the top and bottom that was hidden. Now I see it, I could kill it. So now I have what left? 1 over 2 times this business. And what do you get when you let x equal 0?
Is it -1 on top?
Is it? Yes. Thank you. So what do you get down here if you let x equal 0? What's happening?
Three.
Get 6 inside times 2.
12.
Cool. Now that you did some algebra, you removed the problem. Now you made something that is determinate. I like it. And just, somebody asked something last time about why you're just allowed to plug a 0 in because you're not supposed to get to 0. But this, what we did here is we said that this expression is equivalent to this expression everywhere except 0. So what this expression does at 0 is what this expression wants to do at 0. Does that make sense? So this step is legal because of the fact that I don't get to 0, but now I made an expression that does everything this guy does except right at 0. But that means that if I plug 0 and I see exactly what this guy would do in the table, I can just see the answer directly instead of getting all these approximations in a table. The power of algebra compels you. All right, what about this guy? I saw some stuff happening that I didn't like. Yes, sir?
So for I'm totally taking a shot in the dark here, by the way. I'm not super sure. But for the denominator, you can kind of just put those over 1, and then can you multiply those by the reciprocal on the top? Or is that not what you want to do? You're giving me crazy eyes.
Yeah, no, because you can't do anything that would affect each of these in a different way or something. You have to do to the top what you do to the bottom. And that means the same thing is going to happen to both of these. Now, when I see something like this, or when I see something like that, what should you think? Yeah, LCD? If I can make the top a single fraction, I know how to divide fractions by things. I multiply by the reciprocal, right? But I currently don't have fraction divided by fraction. I have fraction expression divided. Oh, shit. So let me put these guys into one. Let me consolidate them into one fraction because then I know what the shit to do. Now, there are other kind of ways to do this, but this is the most direct way. So what's this first piece need? Him, compared to him. He doesn't need a 4. What's he need? 2. Because then he'll have a 4 like that guy does. Always look at LCD like trying to be really fair. He's got a 4. I've got a 4. Okay, now you got a 4. Shut up. What's he missing? X. It's probably good that I don't have kids. He's got ice cream. I don't know. No, nobody has ice cream. Get away. So what do you get here? We get 2 minus x on top, right? Over 4x divided by, so times the reciprocal of the bottom. Let me stop here for a second. Is that cool, everybody? I got the top put together into one fraction. Divided by this means times the reciprocal, just to make it easier to look at, instead of having fracception, like fractions inside of fractions. Now what the hell do I do?
Can you factor 2x minus 4?
Totally. And you want to be kind of smart about how you do it. How can you make it match with this guy? You actually, instead of taking a 2 out, you take a... If you take a 2 out, you get x minus 2. Is it the same thing? Of course, you could just do that, but when you cancel them, what's going to be left? So if I do this, can I really cancel these? No, unless I realize that when I cancel them, I'm left with a -1, because they're not the same, they're opposite signs. What's 6 divided by -6? Freaking -1, right? So what do I have left here? I got limit, x goes to 2, -1 over 4x, is that cool? Times 2, whoops, there's my little 2 dude. You always got to find your survivors. And so what's that become?
What is the bottom number right there?
8. Poor little 8. Some mutant 8. Little hunchback 8. Because I forgot my little 2 there. What am I letting x go to? 2. Maybe you guys don't want to say because it's so damn easy. What do I get then? Yes. Yes? Maybe? No? What's up? What part
It's
did
just
you
the-
not like?
No, it's just the tendency to want to solve for x instead of plugging into this make.
Oh, I see, yeah. So you gotta
mistake.
really kind of used to, this notation on one level is sort of like f of 2, but we understand that this notation means I don't actually get to 2, but it is, if I remove the problem, then I can just plug 2 in. That's the whole idea of a limit. So to do it algebraically, if I can find a way to remove the problem, then I can actually just plug this in. So that's exactly what we're trying to do algebraically. Can I always do it? No, just like the tangent one before. There's no algebraic thing that can do that. There's some calculus stuff I can do, but we don't even know calculus yet. Yeah.
I just have a question. Why you wrote like 2 from the beginning?
Here?
Yeah, yes.
Because what number does this guy have?
4.
And so he's got to have a 4.
Okay.
And what variable does this guy have? X. So he's got to have an X, and now they both have 4X on the bottom, right? That's how LCDs work. So you see the parts of it. How do you make each part become the same? So you look at the numbers. That's 2, that's 4. Give him another 2. X, he doesn't have an X. Oh shit, give him an X. Now everybody's got a 4X, right? Yes? Oh, thank you. Oh, poor little dude. Oh well. He just doesn't want to focus. Oh well, okay. Thank God you're here. All right. Any questions on that sheet? Yes?
Yes, how did you get to -1?
Yeah, let me do that a little cleaner here. Let's redo this one. Okay. So if I multiply times 2 and times x, so let me just take this real slow here. So I get 2 minus x over 4x over 2x minus 4. Is that cool?
I actually got it. You don't have to move forward.
Is that cool, guys?
I don't.
Yeah, I had a feeling. So limit as x goes to 2. So what I can do now, just to make it easier to look at, how to divide a fraction by something, I multiply by the reciprocal, right? So you just kind of pull this to the side, so it's just easier to look at now, right? And then between these two, let me do this a slightly different way. I can take a -1 out of this one, and a 2 out of this one. And now I have the same factor on the top and bottom, right? Is that cool? So then these die. And then I can put a 2 in. So we get -1 over 8 times 2, -1/16. So I love that idea of removing the problem. Algebraically, you can do it. So if you graph this function, if you graph this function, it will have an open circle at 2. Where will that open circle be as an output? -1/16. Okay, I like it. Okay. Any other questions on that whole sheet there? These are the kind of questions I love to ask on quizzes and tests, by the way. This is so nuts and bolts, I can't really change it too much. So you know they're going to have a problem like this, right? You know you're going to have a problem like this. You know you're going to have problems like these. I mean, I can't change them that much. Algebraic, computational, visual. I like it. Okay. So a little bit more. I want to go back to 2-1 now. Why are you so blurry? Poor little dude. It'd be better if I put you closer. There you go. Okay. So just to remind you guys, so you have the idea of limit. We're going to look at several applications of limits, but they exist by themselves. They are their own idea. We use them in several specific ways. Then you have what calculus is trying to do. It is trying to figure out the slope of any function anywhere, right? So algebra had an easy-ass job. Here's a function, it's always the same slope. So if you find a slope here, it's the same everywhere. It's like, all right, that's great for you, algebra. We have this shit that does this, right? Or even this, right? So we're going to have a little bit more difficult time. I can't just give one answer for the slope. My answer for slope will be a function, because every x value is going to be different, possibly, right? Different slope. I enjoy it. I like it. So the fundamental idea then is, given some function, if there's a point at which I want to know the slope, algebra kind of laughs at this and says, good job, good luck, because you need 2 frickin' points. And we already talked a little bit about this, but what I do then is, that if I want to know the slope at a point A, at a value A, I artificially create 2 points by going a little bit away from that, A plus H. So that H for us is going to mean a very small number, normally. Because we're going to let H do what? Who remembers? What do so right now, can I get a slope between those 2 points?
Yes.
Yes. But I want the slope right at that point. That's just an approximation. And in fact, for my picture, it looks like not the best approximation. How would I make it a better approximation?
Move H closer to A or 0 or whatever.
Let H get closer to 0 so that A plus H becomes closer to A. I love it. I like it. So in practice, what we do is this. Let me show you what it's not until section 2.7 that we write the thing I think I already wrote for you, which is really what we're doing is, what is the slope between these 2 points? What's the slope between those 2 points? Yeah, over A plus H minus A, which became H. Remember that? And I know now I'm going to do this to it. And then the answer will be the slope at A. If I put an x here instead, I would get the slope at any thing. I just have to put the x value in. So what section 2.1 does, which is slightly infuriating, but it's okay, is it just gets it right down to like real nuts and bolts. So this will be section 2.7, if I'm not mistaken. But do you see how we got everything we need to get to write this? We understand the idea of limit better than we did before we heard about it. And this is just algebra. This is just y2 minus y1 over x2 minus x1. So if you marry these 2 things, you get calculus. You get the slope at any point. If you put any point you want in there, you're going to get the slope out at that point for any freaky-ass function, right? Okay. So what 2.1 does is this. Let me give you, I actually have something I'm going to show you that's kind of cool, but like problem number 1 in 2.1 has this table. Let's see. So this is time and this is volume. So if you have your book, you can see this problem, just in case you don't have it. I could have put it on the overhead, Jeff, but it's too late. You're invested now. There you go. So for this problem, they're calling this guy point P. And that's kind of like the point that we want to know the slope at. So let me give us a visual of this function. So here's what this calculator is capable of. Oh, shit and a half. Oh yeah, turn him off. Give me a second. Get out of here. Let me turn him back on. Let me clear this dude out. Go away. Clear. Go. Okay. There we go. So those are those points graphed. And what I've done, somebody ever taken any statistics? Remember linear correlation where you had a line of best fit? So this is the same idea, it's just a curve of best fit. So this is a quadratic curve. It fit it really, really, really well. If you have no idea what I was just talking about, I just averaged where all those points are with that function. Do you have to do this for this problem? No. I just want us to see a visual. So the point 15 to 50 is that one right there. So if I get the slope between these 2 points, that's going to be a decent approximation, but that looks like it's going to be a little too negative. Do you see that? It should be a little more positive. If I get the slope between these 2 points, that's a little too positive. So how can I estimate the slope at that point? Immediately, I can take this slope and average them. That's exactly what this problem asks you to do. That's exactly what a few of those problems ask you to do. Now, to be honest, what's a more direct way where I only have to do one calculation? I can get this. What would approximate the slope here would be the slope between 2 points on either side of it. Now, is that always true? Do you guys see what I say when I say this is a well-behaved function? It's like if you're in a plane, you're like, I'm cool with coming in on the plane like this. But you could have a function that's like just up and down. You want to be on that plane? No. Yeah, I know. I'm missing everything. It's fine. It's probably better. They didn't see that shit. Yeah. Good plane, bad plane. So when you have functions that are going insane, you can't go this far would be really far away then. Do you guys kind of see what I'm saying? If this function is going like this is really far apart. They ain't going to approximate shit. You can't get that far away then. The idea of far away in math is a very important one. This is our first attempt at defining far away, letting the distance get smaller and smaller. Okay, maybe. Okay, so let's see. This is a very, very, very nuts and bolts section, section 2.1. Very nuts and bolts. So let's see what the shit they ask us to do and how to do it. So you're not hanging out to dry on your homework. So what they're going to ask you to do is they're going to ask you to figure out the slope between P and every other point. That should be easy, right? So let me call this Q1, Q2, Q3, Q4, Q5. So what's the slope for Q1P? How'd you get that slope?
694 minus 250.
Yeah, good. It would be y2 minus y1 divided by that. And we know it's going to come out negative. We know the slope should be negative, right? So this kind of makes sense. Then you just do it. Then you just do it for every single pair of points. Are you guys with me? So it's it's just purely rooted in algebra. Now let's just jump to the chase here. Can you guys take a minute and figure out the slope for Q2P and for PQ3? That would be this slope and that slope. Just to make sure everybody can do this on their own. All right, write it down yet. So this would be what over what? For Q2P.
Just the slope of
It's just the slope, yeah.
negative 39.
Oh, I'm sorry. So let me catch up to you. 444 minus 250, right? Divided by 10 minus 15, so you get negative who to what?
39.8.
39.8? Is that what you guys got? All right, I got one person say yes. Okay. Is everybody okay? You guys able to get that number? You'll have to do this kind of thing in the homework and the test. Probably want to make sure. 38.8? Okay, so that's what the consternation is. Let me see. I haven't done it myself yet. 444 minus 250 divided by -5. 38.8, yeah. So when I crowdsource things, I didn't do it. I don't know what the answer is yet. Seeing them crowdsourced it. What about this one? PQ3 would be 111 minus 250 over 20 minus 15. Negative 27.8. Okay, so if you average those two, what do you get? Yeah, negative, right? That's what they're going to ask you to do in the homework. You're just finding a series of slopes. But do you see how this ties in with the limit idea? They just haven't talked about limits yet. I'm doing the limit as my points approach this point. Right? But they're not putting it in that notation yet because we haven't even talked about it in section 2.1 yet. So I kind of don't like the order of things, but oh well. I'll get over it. But let's check something. What is Q2, Q3 slope? That would be, oh, it's gone. That would be, remember that we want the slope at that point. So I can use the secant, just to remind you guys, the tangent line is the one that touches there. The secant line is the one that goes through 2 points. And there is a connection with the trigonometry, in case you're curious. All right, we'll see that later this semester. But tangent line hits it just at that 1 point. It is where something is keeping this, and if the track falls away, it's where the thing it's the direction it would go in now that it's not being pushed in a certain direction. So if I was swinging something over my head, the slope at a point on the circle would be the direction it would go in if I let go, right then. You guys kind of with me? So right here is the direction it would go in if it just kind of was allowed to just keep going. So secant line is the one that goes through 2 points. Tangent line is what we're always trying to approximate at that 1 point. I like it. So to do this, what would it be? It'd be 444 minus 111 over 20 minus, 10 minus 20. Don't you get 33.3? Right? Negative, yeah. Isn't that exactly what we got over there? Doesn't that kind of make sense? It's not always going to happen because the worse the function is, the more careful you have to be about how close you get. But this is a nice function that's fading away. Phi function. So if I do just straight through there, that should be parallel to this one, roughly, especially because it's a nice function. Okay, maybe? Okay, I like it. That's basically all the problems in section 2.1 are related to this procedure. Okay. So, let me make this official. Our first quiz. Chapter 1 through section 2.3 will be next Wednesday. Not Wednesday. You gotta excuse me. Thursday. A week from today. Okay, I think I told you guys I don't do pop quizzes. So if you miss a class, you probably want to ask, hey, I missed, is there a quiz coming up? Or watch the video. Okay, I like it. Okay, maybe. So let me see if they throw anything weird at you. The way they give you the question gets a little bit weird. For example, let's look at number 6 real quick. Just so you see what you're supposed to do. So number 6 gives you this. This is 6 and 2.1. What was it? 10t minus 1.86. T squared. This is a velocity. Oh no, it's a position function. Yeah, it's height. Okay, so this is height of an object on Mars after you throw it in the air. On the Earth, it would be something like something t minus, well, if you do it in our stupid ass units, it would be 16 t squared. if you do it in the units that every other country on the face of the frickin' earth uses, metric, it would be 4.9. These numbers here, these are related to gravity. Right, so on Mars, obviously it's got less gravity, that's why that number is smaller. So it's going to pull you back with less force. Maybe. I like it. So if I threw something into the air, why is this a negative term? Because it's going to try to take away from the velocity. It's going to slow down and then drop back. As long as you don't go fast enough to escape the escape wall. Anyway, all right, more than you had to know for this. They ask you this. Find the average velocity on the interval. Where'd it go? Let's just do this one. 1 to 2. This is seconds, right? Yes. Seconds. Oh, this is meters. I like this. This is meters per second. Oh, yeah. This will actually be meters per second squared for acceleration due to gravity, but screw it. You don't have to know all that shit. This is a different way to get the same problem we just did. What are my two t variables I'm going to use?
1 and 2.
1 and 2. So t equals 1, t equals 2. And then what are the y values I'm going to use? Well, I just got to freaking plug 1 in and 2 in to get the y values. So the first one gave me the whole completed xy table, right? Or whatever table. TV, I think it was. Right? Because it was T for time, V for gallons, volume. This one just gives me the input values, so I got to plug them in to get the other part, so then I can get the slope. You guys with me? So it's the same question. They just give you the inputs. You got to put them in, get the outputs, and then get the slope. And then the next question is going to be remarkably enough 1, 1.5, and then 1, 1.1. So where are they curious about what the actual velocity is? If I let it 1, 2, 1, 1.5, 1, 1.1, I'm getting closer and closer to 1. They're curious at 1 second, what's the velocity then? Right? That's how it ties in with the limit stuff that comes later. Okay, I like it. Maybe. Okay. All right. I think this is perfect. All right, cool. We're going to do a little field trip, and we'll end up getting out officially a little early, which kicks a lot of ass. So pack up. It's going to take me a minute to get all my shit together. So can you guys just start walking towards the Tuck Mall very slowly until I shoot out in front of you, okay?